A long time ago, in a galaxy far, far away, the world was divided between code and database. On the code side, we have languages as C++, Java, Delphi, PHP, Python, Ruby, Visual Basic, or C#. While on the database, we have things like MySQL, Firebird, Oracle, or Microsoft SQL Server. General-purpose programming languages are meant to be used to design solutions that will run on memory. Databases, on the other hand, are used to store information on a hard disk. When coding is all about algorithms, user interfaces, and communications, while databases focus on queries, persistence, and transactions. When coding, we model the world using classes and objects, while in database it's all about tables and rows. They solve very different problems and they are condemned to work together. Unfortunately, making them speak to each other is not that easy. Let's see an example. In order to execute this simple query, you have to create a new command, add some parameters, use a data reader to retrieve results, surround it with an SQL connection, maybe do some error handling, and very often also use a transaction. Too much code. So, ta-chan! Clever idea number 1. Object to relational mappers. What this technology usually does is to place an XML between your entities and your classes. This way you can write clean code that saves, retrieves, and deletes the entities without you having to dirty your hands using SQL directly. The famous ORMS Hibernate for Java and the .NET port Hibernate are a good example of this strategy. Other products, like Subsonic and Entity Spaces, use code generation. Rails for Ruby use active records, while the Django writes the model straight in Python. However, when it comes to queries, they are really disappointing. If they have any support, they usually force you to use a string-based language, using a specific syntax with a really poor expressiveness. And ta-chan! Clever idea number 2. LINQ, that stands for Language Integrated Queries. What this amazing technology does is to provide a common syntax to express powerful queries that contain select, where, joins, group bys, order bys, and any kind of aggregate. Also, it does in such a way that is completely integrated with the environment, so you get compile time checking, auto-completion, and refactoring. The whole LINQ thing is based on lambda expressions, an old technology that comes from functional languages such as Scheme, Lisp, or Haskell. So that's it. It's over. When Microsoft designed LINQ, they did it with extensibility in mind. But none of the main ORMs are doing their own LINQ providers. However, Signum Software, a small company in Spain, thought that there's still room for improvement. So, ladies and gentlemen, here it is, clever idea number 3. Entities first. With any previous technology, you usually start by creating the DB schema. Then you write your application over, using custom classes or datasets to store the information temporarily. Who knows? And finally, you write the user interface. In our model, the first thing you do is to write the entities in a language like C#. Then, the schema is automatically generated from the entities. And also the entities have a big impact on the user interface. But it's not just a matter of order. We force our entities to inherit from some certain base classes, and the way they have to be related, and how laziness have to behave. We have a solution for validation. These solid foundations have a big impact in the rest of the system. For example, and this is bad news, you are no longer able to use your legacy database. Instead, you will have to create a new one. This radical decision, however, pays for itself because it enables huge improvements in productivity in other areas. Let's see. Unified validation. In our previous model, we usually have validation spread all around the system. Maybe we have some triggers in the database, and some checks in our business logic, and also we are forced to replicate these checks in the user interface in order to improve experience. With our model, however, you usually put the validation straight on your entities, where they should be, so they get checked just before going to the database. And also, since the entities can be serialized, the same validation are applied in the user interface in a very nicely integrated way, so you get a very responsive experience for the users and they are happy. 1 point for Signum then. Second improvement, Schema Generation. We agreed before that we are no longer able to use our legacy database, but how this new database looks. Our database will be automatically generated or synchronize from a set of entities you choose using a very simple one-to-one mapping from entities to tables. This way, the database ends up being highly normalized and carefully indexed using a very simple name convention. Just the way you do when you have the time. So, second point for Signum. Third improvement, user interface simplification. If you think about it, all we do in our code behind files is linking user interface controls to our data store. But now, thanks to the homogeneity provided by our entities and a unified way of reaching the server, we can build controls that need just no code behind. These controls can also deal with validation. The simplification is so big that an entity with 4 fields only needs 4 lines of sample code for the user interface. And since they are just WPF controls, you still can do whatever fancy effect you want. Fourth improvement, Centralized Service. If you're planning to provide a smart client to your application, you're gonna need a service to communicate with the server. Having a solid foundation for your entities also have an effect here. Instead of having 3 different methods for saving, let's say, customers, products, and bills, you can have one single centralized save method. This way you save a lot of code. And last but not least, the 5th improvement, model integration. Thanks to the solid basement of our entities, now you can have vertical models that goes from the user interface to the schema across your custom entities and business logic. And just by linking the entities of different models together, you get a nice integration of the user interface and the schema. This is a completely new turn to application composability. So, the 5th point for Signum. Let's see all this in a real example. Let's pretend we are building an application with many different areas. We have the typical model for authorization, another for stock, another for bills, and some others. Using the basic and layer stack, nothing trendy here, you end up having all this code. We have our user interface, maybe writing in SAML, and the code behind writing in C#. We have the service to speak with the server, writing in C# as well, the business logic in the server, the data access, and maybe some store procs writing in SQL. Finally, we have the schema definition. If we use some ORM technology, we save ourselves from writing the store procs. We also save a lot of data access code, but we still have some queries in there. However, it will force us to create a new layer for the entities. And also, we have to create an XML mapping between the entities and the schema. If you use a modern LINQ technology, like LINQ to entities, then you completely remove data access code, queries included. Also, the entities and the mapping are automatically generated using a cool designer. You still have to maintain it, however, so we will keep it in gray. Now it's time for Signum framework. With Signum framework, it's your work to write the entities. At least you don't have to write any mapping. When you write the entities, however, you place the validations in there, so lots of code from your client application and your business logic just disappears. The schema is automatically generated, even synchronized, but just in case, we will keep it in gray. Also, thanks to the improvements in the user interface, we remove almost all the code behind, and the sample code gets reduced to a half. By unifying the services, we also get rid of a lot of redundant code. And more important, as time goes, we will end up reusing the same vertical models over and over. Some of them will be provided by Signum software, some of them will come from the community, and some will be just parts of previous projects you have done with this framework. In this example, let's pretend an authorization and bills model are already developed, so we'll put it in gray as well. Look at how little code you have to write now. And since code is your worst enemy, that means less bugs and easier to change. And now the really good news. Signum Framework is an open source and completely free to use technology provided by Signum software. If you want to see some actual code, look at our tutorials. That's all. Thank you for listening.